Okay guys, since I've got 17 then, we're going to sketch 2 tan 2x. I've got the tan x function just sketched out quickly because we're familiar with drawing that. So it goes 0 to 90 and it shoots off to infinity. Well, tan 2x, when x is 45, this will be the 90, won't it? And tan 90 is infinity. So the value that it shoots off to infinity happens not as it goes up from 0 to 90, but as it goes up from 0 to 45. So we better put a little asymptote in here at 45, hadn't we? Okay, and it's going to shoot off to infinity. There, so let me put the marker in there. And it shoots off to infinity. Now, remember it just swings up and back up to 270. That's going to happen half as much, isn't it? So when x is 135, it will be the value at 270. So 90, 135. Let's put that in. Let's do another asymptote. Okay then, and as we said, when x is 135, 2x is 270 and it shoots off to infinity. And then when it's at 90, 2 90s are 180 and the value of tan there is 0. And when it's 45, tan 90, it shoots off to infinity, but then just above 90 it shoots to minus infinity, doesn't it? So it's going to come down, through, and down. Okay? So let's just draw those first two parts then. It comes down to here, like so, quite steep, and then it comes down, through, and down to there. Now that's the characteristic shape, isn't it? It's just going to repeat after that. So 45 to 135, then another 45. So this would be 225, wouldn't it? And then 270 and 45 is 315. So I'll just put that in, like so. So every 90, 135 to 215, so that's where the asymptote will be. Yeah, that's our 225, 135 to 225. So it's going to shoot up there, down to there. So let's just draw that in now then. Like so. And then the next 90 that's going to happen will be 225 to 315. So we better do an asymptote there, hadn't we, at 315. So sorry about the mess, I'll tidy it up in just a second, but let me just get this done. It's going to shoot to infinity through 0, minus infinity. So let's draw that. Like so. Let's try again, just another go. Like so. And then that was up to 315. And then basically the curve will carry on in the same way from 315 to 360. So it will just drop to minus infinity there. Come down from 0 down to minus infinity there over that last 45. Okay then. So let's just get rid of the original plot I did of the tan function. And that's the sort of function we're going to end up with. So let's confirm that on the plot then. So I've written 2 tan 2x. One little thing about 2. That was tan 2x. It sort of concertinaed it up, didn't it, by a factor of 2. And then it just elongates it. But because of the characteristic way that the tan is drawn, it only affects the scaling here, doesn't it? So that form will look similar no matter what this value is here. It will just look the same characteristic sort of shape. So let's have a look at it generated then. And there we go. Yeah, so let's just confirm it. 45, 90, 135, 180. Yeah, pi. And then 225, 270, 315, and then the last bit, the 360. Okay, so that's good. We've done that one then. That's 17 done. Great, let's go on to the next one. Good.